Thank you. This is our first, what we call a community outreach workshop. These were formerly called working groups. And the point of these things for the last couple of years is that we want to have a more in-depth presentation and really get into some things so that people can understand these projects better, and then also have some extended time for questions and answers and comments so that we can get feedback about our projects. Now, in the future, we'll advertise this a lot more heavily, but when we get to a point where Vista is like at its 90%, we will have another one of these. And like I said, we'll advertise it a lot more heavily to make sure that we get community involvement. But this is actually kind of a retro view of where we're at with Vista, carrying it into the final exam, or not the final exam, the final design. So people kind of have a catch up on where we've been with this project and where this project is going. So it's a nice catch up, kind of a presentation. And like I said, in the next few months, we'll actually have a 90% presentation that will really get into all the later stuff that we've been working on. And we do have somebody already working on this right now. Um, I think that the first thing that I'd like to do is just go ahead and get into our talk. And I do have a talk ready. And it's a bunch of slides. And so I'll put that up. And where is that here? Okay. I'll go ahead and share, and we'll go to, there we go, get that off of there. Where'd it go? Just went away. I'm sorry, my presentation just crashed.
I can run it as backup if you want.
No, I got it now. I saw what I did. I did something stupid.
Nah,
So
okay.
that's just me. Okay, so let me get back. Oh, okay, let's see what we got here. So do you see it's Vista Narrows and a picture of the Truckee River?
That looks good.
Okay, great. So to start off, just to let you know who I am, I'm the executive
How do
director
I
of the
get to the
Truckee.
picture? I can't.
What's that? Somebody having trouble?
Oh, I had to mute somebody. It's okay.
Oh, okay. So this is this I'm the executive director of the Truckee River Flood Management Authority, and this is about Vista Narrows. It's a very important project, a little bit underrated, I believe, compared to some of the other projects, but it is absolutely necessary to do, as you're going to see in this presentation, to be able to do the other projects. And this first slide right here is interesting because you're looking at a river and you can see this low floodplain over here on the right side of the picture. And that is what Vista will be like. There will be a very low floodplain where the water can easily come out of the river when it's not even flooding that much and get in there and replenish the groundwater and also spread out this water so the velocity is moving slower, the river's moving slower, and also the river level is not so high because the water is spread out. That's the whole theory behind the Vista Narrows type design. So let me go ahead and look at this. So to give you an idea where this is located, this is kind of a bigger picture map. I haven't pulled one of these out for a while, but this reach right here we call the Truckee Meadows reach, the Meadows reach. And this is where most of our project elements are. This is where the flood damage occurs. It's from the 580 freeway bridge down to Vista. And really, over $2 billion worth of damage occurs in this reach when we have a large flood like 1997. Buildings are inundated, inventories lost, businesses go out of business, people lose their jobs. This is the area where the most impacts occur in this range here. And then upstream of this, we have the downtown Reno reach. And fortunately, the downtown Reno Reach, the banks actually go up faster. So while there is impacts, it's more just right along the river, more or less. And then you have the upper reach, which we call the Verdi Reach, which is also the river's kind of higher. There are some places that do get damaged, but it's much more limited. And then, of course, the downstream reach is like that as well. There's much more confined. The river's much more deeper in a canyon for much of this and less damage on average. It does spread out down around Wadsworth, and we are doing some mitigation down there for the extra water we're putting in the river because it does have that kind of a spreading out nature down there as well. So, anyways, these are the different reaches, but the area that Truckee, the Meadows project is really focused on is this area right here, along with mitigation downstream over this area down here. So when you talk about what we call the Meadows Flood Project, we have different components of this. Vista Narrows is down here on the far right. And you can see this is the upper, what we call the upper terrace that we're going to be excavating. And there's actually two more terraces that are off this map. But you can see the Vista Narrows. Then we have the North Bank levee and terracing. We have Rock McCarran project. We have airport. We have the Tumwa levee. We have the GSR Berman levee. And then we previously completed the colonies level and flood wall. So we have all these different projects along here. And the net effect of all this is it costs about $200 million, but it can prevent over $2 billion in damage from a single large flood. And it has a net benefit of year and a benefit cost ratio of cost going forward of somewhere 4 to 1 or better. And Tumwa currently we have 73 million saved. So we're short 130 million, but we do have a cash flow of 11 million per year that continues to be saved and can be used as collateral for a loan. And we also have downstream, we have mitigation. We have a mitigation agreement with the Pyramid Lake Paiute tribe, $17 million total, a Wadsworth pedestrian bridge replacement that's in process right now. It's actually under construction. And we're talking about a future very small berm at the Rainbow End area near Lockwood, which is downstream from here. So we have a lot of different things going on associated with this project. And we even do targeted projects upstream as well and down in the floodplain south of this map. So why are we doing this? Why are we doing this is because we want to take this area in a large flood, all this in blue becomes flooded. And then if we do build the Meadows project, everything in green is taken out of flooding. And so this area, like I said, this encompasses the Sparks industrial area down here in the downstream part where my cursor is. Then you have the kind of the west Sparks industrial area. Then you have the GSR area, the airport, and the Reno industrial area. These are all lots of jobs in these areas, lots of people work in these areas, some housing. And taking all this out is a huge amount of the total damage of a flood. It amounts to 75 to 80% of the total damage you'd see in a large flood in the Reno Sparks area. So what is the Vista Narrows project specifically? The Vista Narrows project specifically are basically 3 terraces. We used to have up to 6, but through various analysis, we did very detailed modeling. Our consultant did, which is Atkins Realis, with a team of other consultants such as HDR and JUB and others. But with that team, we had a very detailed model, 2-dimensional model, and we did lots and lots of iterations to figure out how much do we need to shave off here to create a flood flow that keeps the water level down upstream, but minimizes the amount of water that's going to go further downstream. So limit the water upstream, but not have too much water going downstream. So that through that iterative analysis, we were able to get this to a place where these three terraces look like what we're going to be doing. And in the final design, we even have now a more sophisticated model, and we're going to double check that and really hone down on these terraces and possibly get this project to where it can actually save a little bit more money than it already is going to save by going from 6 terraces to 3, and also get this the optimum for the water level versus the peak flow downstream. So you can see that the idea is to spread the high flows across the wider area. Um, and it's very different than what was done earlier in about 60 years ago. The Army Corps of Engineers came in and took out basically a rock outcrop that they call a reef. They blew that up, and it actually changed the grade of the river, caused the river to downcut upstream, and then do a bunch of sediment deposition downstream, and it just created a kind of a mess. So what we're trying to do here is not mess with the river itself or the river level, but rather restore the floodplain, allow the floodplain to allow this water to spread out and lower the water level that way. So it will not create those problems that old approach did. So the history of the Vista Narrows project is Vista was done at first um, because, or was always going to be done because it provides mitigation for the rest of Reno. The thing is that you'll see this in a future slide that I have, but there's a lot of water stored in the airport, in the industrial areas. And when you do all that with the industrial areas, and then you dry them up, all that water now is going to come down at once, and it's going to create a higher water level backing up into the university area and also into places like Pembroke, Hidden Valley, those areas. So we don't want to like create a better situation in one place and make it worse somewhere else. We want to make sure that we're not making the situation worse in other parts of Reno and Sparks. So what it does is it lowers that water level to make up for that loss of storage. And this has been going on. This idea has been around for about 25 years. However, serious design, and I'm not talking about like people's ideas and sketches, a serious design on this has not ever been done until the spring of 2018. And that culminated in a 65% level design in 2019. Now, originally, it was to be part of the core authorized project as part of a locally preferred plan, but the Corps rejected the locally preferred plan in 2019. And then TRFMA, in turn, rejected the Corps' plan that was their original plan because it didn't have Vista Narrows and it had way too much cost associated with trying to fix all the problems that the project would create without Vista Narrows. So we rejected their plan. So basically, we don't have a plan with the Corps, and so we were deauthorized, and we are moving ahead without the Corps of Engineers on our plan to do a project where we are using Vista Narrows to get that mitigation in the Reno Sparks area so that we don't have a water level problem in UNR or out at the areas around Hidden Valley, Pembroke, those areas. So what I was saying is that yes, a lot of water is stored in these green areas. You know, when it was originally flooding, there's some of these places have 10-foot deep water in some of this area here, some of these areas right in here that is no longer holding water anymore if we build the project. So that way the water comes down here way faster into this area and raises this water level without the effect of Vista Narrows. So when you open this up a bit, that allows that water to come out and keep this water level at or below what it was originally. And so that's what this looks like. So everything in green is actually a lower water level. This would be almost the same. This is up to about a foot difference. So you can see all lower water levels because of Vista Narrows with the entire project built out. These other colors are actually rises in water levels, but that's staying within the river itself. This is all staying within the river inside levees. But the point is here it's all lower, and that's what we want. We want a no rise, a no water surface elevation rise, so that we don't have a problem here and cause more problems for people by drying out these other areas. So how do we do that? What does it look like? This is a picture a few years back of Vista Narrows, and you can see this bank is 15 feet high. And you can see the vegetation on top of that is something called white top, which is a very dry species, introduced species, sagebrush and things like that. This is a floodplain or a high terrace disconnected from the river because the river has downcut. So that's 15 feet right there. And so the idea would be is to cut this down to a much lower level where the river can interact with that, with more natural vegetation such as cottonwoods, willows, other species, so that you can create this area where the water can spread out to the south here at this particular terrace. There's two more terraces downstream where we would be doing the same thing, one on the north bank and one on the south bank. But this one right here, the big terrace, is on the north bank. And the idea is to cut this down. So here's another example. We have cut banks. See how high this is over that. That's probably 15 to 20 feet there. And what we want to do is, now this, we don't have any room for this, but we would be armoring this somewhat. But the idea is you want to get this more reconnected to the floodplain, not here per se, but like I said, we want to armor this up so we're not having all this erosion going on. So you can see here as you flow into where the Vista terracing is, this is just upstream. It's a very constrained place. This is the Tum Wharf water treatment facility for all sewage water, and it comes out very clean, good water, but not perfect. So, but the idea is that this improves the water quality, but it's right up against the river. And then you see there's other developments. I saw Dick Mills in the audience. I know he's very familiar with some of these properties because he owns them. But the point is, it's a very tight area here, and it remains tight down here at the bottom of this picture. And the idea is to move this south bank, and not move the bank or anything, but actually lower the floodplain on that south side. So here's that south side, and you can see how tight it is right here. It's to bring this down, bring all this down right through here. 450,000 cubic yards of material. Doesn't look much in this picture from the sky, but that's 15 feet of material there that we'd bring down, probably 10 to 12 feet of it for a large area to allow this river to spread out during high flows. And you can see it over here. Now you can see how deep it is. Very high bank here. And so you excavate this down, and that's how you get this condition where we don't no longer have these degraded cut banks. We have a restored floodplain with natural vegetation that's less apt for sedimentation. You also have water flowing out over this that lowers the water level, and it's slower, so there's less chance of erosion as well. So this is what it looks like in a cross section. This is the original height in this particular cross section. And this is just one example, and it's simplified. We have dozens of design drawings where it's very detailed of exactly what you do. But the idea is to have a very flat area, then a gradual up, then another intermediate floodplain, a little bit up. And this is pretty much you're up on the top here. but you actually don't catch up all the way up to here. So it really all this area now is open for flood water to flow through where it was just over here. So you're really opening this up is the idea. And we'll have a talk after the talk I'm giving about kind of the environmental and what this looks like in terms of vegetation, environmental, etc. This slide below here is actually down in the lower reach where this was spread out. And you can see how wide this river is, and it slows it down and it allows native vegetation to start growing on the bank, native vegetation over here, but also just slowing it down, widening it out. So it's much more connected with its floodplain. You get better groundwater and also just lowering that water level. So what is going on with Vista Narrows? I mean, we use the word hydraulics, but that's just the water behavior, if for lack of a better term. It's what is the water doing? What is the water? What are some of the goals? What is going on here? Well, we want to avoid impacting low flow, so we're staying out of the channel. This is all out of regular channel. These are terraces and floodplains, not in the channel. We want to pass the 100-year flow, and we will have more capacity here because we are spreading out the flow than we already did. We will provide upstream water surface elevation, WSE reduction, and that will allow the water upstream to actually be lower than what it was even before the project, is slightly lower. And that helps with things like we have the North Truckee drain coming out right in this area. And so right in this area, it would be nice to have the water level lower so it doesn't back up through that drain, for instance. You also want to balance the flow increase with downstream impacts, and we've already kind of been doing that. That's why we only have 3 terraces now. And it's been iterative as well to figure that out. And we'll probably be doing a little bit more of that in the final design because we really want to get to what we call value engineering. Only do enough construction to meet our goals, not more than we need to do, and really be cost effective. So Vista Narrows has a lot of constraints. We have the railroad, the Union Pacific Railroad. We have I-80 coming through. We have Sparks Industrial Area. We have Tum Wharf, and we have the general topography of the area, which is steep along here as well, especially down in here. So we have all these different land uses, and we have to work with every one of these. This is BLM, for instance. This is City of Sparks. This is the railroad. We have I-80 corridor. We're working with them. So we have to work with a lot of partners here to make sure that we are not doing anything harmful to them, and we're creating kind of win-win situations wherever possible with this project. So what makes it challenging is all those easements. That's very challenging for us to work with all these different people and make sure we can get the ingress and egress for the work and all that. There's also a known landslide on the south side that we have to work within and nearby. We also have to make sure we're not generating sediment and in the dirt that we're generating, find a good place for it. So we're talking with other people doing other work in the area about our dirt as well. And we also have to mitigate downstream impacts that this project occurs, but actually the whole project, that, it does add quite a bit of water. I'll show you that here in a second. And how do we mitigate that downstream? Because we don't want to just mitigate the impacts in Reno. We want to make sure the people downstream are as in good a shape or better after this project is built. And so we have to take care and make sure that we are making a good effort to mitigate all those impacts that we may be causing by the extra water. So what I mean by extra water, at the very highest peak flow, there is an increase. So the 100-year, for instance, that we calculate using statistics frequency analysis is 21,165. This is right at Vista Narrows. There's a gauge there. The with project, post project, we're assuming we with an earlier model, we found that it went up to 23,563. That's with full project build out, with all the terraces and all the rest of the project, all the levees and flood walls and everything combined. And that is an increase of 2,400 CFS roughly, or about 11%. So that extra water, when it goes downstream, we got to make sure that we are making sure that we're not harming somebody with that extra water. And if we are, we have mitigation in place to make sure that they are as good or better off than they were before. And so that's for the whole project. And by the way, it used to be 3,600 CFS, but through all that work and remodeling and iterations, we got it down basically by 1,200 CFS. So that's by a third. That's basically a third of the flow was taken out by just being careful. Don't lower the water as much, but we didn't have to. We only want to lower it to what it needs to be, not go beyond. So here, this is just for Vista only, and you can see the Vista only, the component that's Vista only is about 730 CFS, or about 3.5% change in peak flow. So these are changes. This is part of that number, by the way. So this 2,400 CFS is an important number because that's what we talked with the tribe, the Pyramid Lake Paiute tribe. That's what we used for all our modeling to figure out what the impacts would be downstream and how or might they need to be mitigated. So this is what it looks like, this is called a hydrograph. In a 5-year flow, a smaller peak flow, you can see we're only around up to 6,000 to 7,000 cubic feet per second, which is a much smaller flow. You can see no real difference in the two peaks because the spreading out, all the things that we're doing upstream really isn't changing things too much from what we already do. But at the 100-year, it increases it because of all that storage that is now lost. We're not storing water at the airport and messing up the airport. We're not storing water in the industrial area and causing literally billions of dollars of damage. We're now flushing it through, and you can see it's higher, but it's only higher for about 15 hours. And it's not always 2,400 CFS higher. It's different levels, but about 15 hours of elevated flow up to 2,400 CFS difference at the peak. So what we did is we wanted to see what that change would look like downstream. And so there was a hydraulic analysis done, which is, once again, that just means water behavior analysis. We wanted to see what the peak flow looked like downstream at all these different places along the stream. We also wanted to see what the water surface elevation, or how high the water is, how the inundation is all along the stream. We wanted to see how it changed velocities, that extra water, and we wanted to see how it changed inundation, how far out you would inundate, and what was the extent of it downstream because of those differences. We also did analysis of sediment and the banks and the habitat. So we had sedimentation impacts analysis. We had stream bed mobilization analysis, and we had bank retreat analysis. So we wanted to see how that extra water might change the form of this river or might do things on this river. And we did this by running it through a model for like hundreds and hundreds of runs to see what that would do for changing it. And so what you come out with is, one of the things we look at is inundation. And this green area is what is inundated, but this white area that's on the edges here is the extra inundation from that 2,400 CFS. So in many areas, there's not much of a difference in this. But in some places there were especially three key areas where we thought there was a difference. But here, for most of this, we looked at it from all the way to Vista, all the way down to Pyramid Lake, and we looked for these differences and whether it was affecting property or something that would be deemed important. Like if it got into here and did something different, that's really important. Like this pit here at downstream from Wadsworth. And we actually remodeled this area in 2D and we found some issues that we didn't see in the 1D. But I'll get to that in a second. But the point is that we looked at this all along the river to make sure that we weren't causing harm. And wherever we did cause harm, we wanted to look for a mitigation solution because of Vista Narrows and the total project. So this is kind of the overall results that in a nutshell. Remember, this is roughly hundreds and hundreds of pages of results that I'm boiling down here. And I can't in a half an hour talk, I'm not going to give you everything. But what we found is we had criteria for high impact. And so we had these kind of criteria like, is there a potential for loss of life? Is there newly inundated structures or infrastructure? Is there increased potential damage to a critical facility? Is there a high potential for increased sediment transport? Any of these things. We found one place where there was, especially with this newly inundated structure, and that was Wadsworth. And then we also, for moderate impact, Rainbow Bend or Lockwood, that area, we found that there is some extra inundation on the roads, not necessarily to homes, but on the roads it's a nuisance. And we wanted to make sure that wasn't a problem. And so we've talked to the Lockwood people as well as the Wadsworth people on what we can do to mitigate that. And we'll show you those solutions here in a minute. And then there was places we just found minor impacts, and here's the criteria right here. The increase in inundation height or water surface elevation. Was there any newly inundated structures? If not, then that was a criteria to put it down into moderate. And you can see there's minor impact areas as well. So these were all looked at. We found in this Wadsworth could be a problem, and we found Rainbow Bend area, some nuisance flooding on the roadways. Those were the two things we found. And then in addition, we also looked at this high potential for increased sediment transport. We didn't find high potential, but we did find moderate potential in a few places. And so because of that, and because of possible channel changes, and they were incremental, as you'll see here in a slide, but we wanted to work with the tribe on mitigation and making sure that they are left better off than what we were before the project. So anyways, we looked at very specialized areas in cooperation with the Pyramid Lake Paiute tribe. These were selected spots, many of these, by the tribe. And these other ones in green are areas where we actually, in the past, in cooperation with others, such as the Nature Conservancy, we did floodplain restoration, like what we're doing at Vista, or like what we're going to be doing at Rock McCarran. So these are previous areas where this was done. And so these are in the dark green. Rainbow Bend is an area that we were concerned about, and we did find a concern with that flooding I talked about. And then Wadsworth, there's some concern that you'll see in a minute as well. But the rest of this, we really didn't find specific concerns. However, there's a general concern about, we do not want to see a degradation of habitat, even if it's incremental. So we did a mitigation agreement with the Pyramid Lake Paiute tribe over that. So this is our sedimentation results. And like I said, those were all minor incremental impacts. And the idea was, is this picking up more sediment? Is this going to change the form of the river? Is this going to create deposition zones or scour zones? And we didn't really see that. Our bank retreat, worse than it already is. There is some severe bank retreat on the lower Truckee River, but we didn't see our project causing that much more of it. However, we wanted to help out with that. And so we did do a pretty sizable, like I said, mitigation projects agreement with the Pyramid Lake Paiute tribe. So getting to why we did what we did, we had existing data. This is from like the 1980s, the model. This is a map of where Long Valley, or not Long Valley, but well, where Long Valley Creek comes in. And this is Lockwood here, and this is Rainbow Bend in this area. And what we found is, okay, there's all this stuff going on, but we're not really sure what is because of this creek and what is because of increased flooding on the river. So we didn't really have a good fix on that. So what we decided to do is do some better modeling. Now, when we did what was called the physical map revision, which was done for redoing the maps, and TRFMA actually funded that and had a consultant do that. We had better cross sections, but even then, we didn't really have enough information to distinguish all that out. So on top of that, we did two-dimensional modeling. So I just want to go backwards here. That's the level of information with the physical map revision, which is much more information than the old model. And this is the new model. Look at all these grids. There's literally thousands of them here. Every one of those grids has got information about elevation, water, what it's doing, transferring, all in a very detailed model. Look at how small those grids are in there. That's right there, that's the rooftop of a home. That's how small these grids are. And the detail that we needed to get an idea of how fast that water was going, what kind of scour was it causing? What deep was it? Is it dangerous? Is it going to sweep somebody? All those kind of questions we wanted to answer. And how much of this was from the creek versus how much of this was from the river? And if from the river, how much are the extra 2,400 CFS if Vista was going to impact this? So there was a lot of questions to ask here. And so what we did, and this is just a blow up of this showing how detailed this is. That's the rooftop of like a 3-bedroom, 2-bath house. So you can see how small these are. Look at how small these are compared to that. So what we did in the hydraulic analysis is we broke out runs that isolated just the creek and then we did runs that looked at the river and the creek together at different levels. So we wanted to see what would happen. And what we found was a lot of what was on that original map was from what the creek was doing at these very high flows. It wasn't minimal overtopping, it was extreme overtopping, even when the Truckee River was running low because of what Long Valley Creek was doing. But then when the Truckee and the creek were going together, there was some minimal overtopping, and that's what we wanted to mitigate, is that, not that. That's not because of our project. We're not mitigating that. However, we did help Story County in looking into that and trying to get some funding from other agencies about how to fix that. So I just didn't ignore that problem, but that's not because of the Vista Narrows or the overall Meadows project. So what you can see here is when you do the 100 and 117 year, you can see there's a little extra water from the 117 year. In red, the blue is just the 100 year. And we wanted to just check and see what this does to this community. We have a considerable flow going Long Valley, but not a gigantic cloudburst thunderstorm flow in the summer. That's a totally different phenomena. So anyways, we wanted to see what the river itself was doing, not the creek. And you can see here's what it looks like. You can note that most of this is dry, all of this through here. That it's not going over the top. There's not this huge area and all that, because it's really the creek that what does that. And we have many maps of what that looks like, and we shared all those with Story County and they actually got a grant to do some further work on it with FEMA. So here's another one, and this is really the key one. This is a 117-year event, so this would be the 97 event flow. And you can see this area in red is because of the extra water from the project. And you can see that water gets on the streets and and it's nuisance water. So we looked at that and we said, well, how can we stop that? Because we're causing that. We're causing the areas in red here. And so we looked at that in more detail. And what I came up with was small berms here, 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 and here. These are only like a foot to 2 foot high, small berms, and if we did that, we would get rid of all of that, and it would be the same. And in fact, it would be better for flooding than it is now. So by doing that sort of thing, we can actually make the situation better for the people there, even with the extra flow from the project. And that's the idea here. And this would not cost that much money. It's in the hundreds of thousands estimate. But the idea is we will probably re-engage with Story County once we work on Vista and really think through how to mitigate issues with the extra water that will be coming in there so that they don't have nuisance water on their roads. So the other place where we saw a real problem along with that was down at Wadsworth, and this was a little more of a serious problem. And the idea is that, these homes along here, there's an old bridge here that really, when the water comes, it really gets involved with the river and starts backing up water. And when we add 2,400 CFS to this flow, there's actually more backing up and more issues. In fact, the water starts to back up and goes down this, gets some more of these, and it does cause a problem. So we needed to find a way to mitigate this either by maybe putting up a levee or a flood wall along here, maybe replacing this bridge or getting rid of the bridge so the flow goes through more smoothly. Maybe that will do the trick. So we looked at all that. We did studies and we did all that and looked at that carefully. And this is an example of the model here. And you can see once again, all this detail of this model, how all these grids and everything. This is a two-dimensional model. And there's a breakout zone here and it breaks out this way and it starts going down. It actually gets in that quarry that I showed in that earlier picture. It actually gets into the quarry. So that's not a good deal. So we looked at, okay, how much water comes across this area right here into this area and makes a big mess essentially. And how does it change because of the extra 2,400 CFS? And when we did that, it wasn't good news for us. This is what happened. The blue is with the increased water from the project. So it almost increased the flow. Well, it did by about 1,000 CFS breaking out with the project. So almost half the water that breaks out is because of the extra water from our project. So that it really creates a problem with that extra 2,400 CFS. So this is something we really needed to do something about. So we looked at lots of different ideas about how to fix this. We actually did a detailed study on bridge replacement, a levee with a bridge replacement, a flood wall with bridge replacement, and then just using fill and building it all up. And we ranked them out, and we actually went with what was number 2 because the people in the area really, if you talk to them, they really didn't want a flood wall or a levee blocking them from the river, but they did want it to be as good or better. They didn't want us to be causing a problem. So what we found that this could mitigate everything. It costs less, and it also allowed people to still enjoy the river and be close to the river. So that was kind of a win-win-win all the way around. And so what you see here, this is what we call a longitudinal profile of the water levels. And this is where the bridge is, the Bridge Street footbridge. And you see how it drops like that? That means it's backing up water. And you see with the original condition is this dark blue line, and with the new condition, it's higher. So you get higher water, and that's where all this water is breaking out and going off the river to the east. And that was creating the problem. But if you fix the bridge and make it wider and higher so it doesn't back up water, the green line is what you get. And so your green line here actually has a much lower level and you don't get this breakout. Now it is higher here because there is more water, right? But even though it's higher, it's not causing a problem because the river can handle that extra water without having property damage or getting into somebody's foundation or floorboards or something like that. It can actually handle that. And so by doing this, you actually have less. So to go back here, to this one, you actually the hydrograph now is at less than what it was before. So I'm actually improving, or the mitigation is improving the condition here, with or without the project. And because it was such a good project and it did so much good even without, building Vista Narrows or the rest of the project, our board voted to do this regardless because it was such a good project and the bridge was wearing out and everything else. So that is a great example of doing a lot of study, getting a good mitigation solution on a bridge. But you think, wait a minute, I thought Vista, that's up by Sparks. What are we doing down here in Wadsworth? This is downstream mitigation. You have to look at every effect that you have and make sure that you're leaving people in a better position than they were before. So the mitigation solutions after the analysis and community discussion, this has already happened. Rainbow Bend, we discussed, we had a community meeting, and we're going to revisit this after Vista proceeds further. Like when we start to get in construction, we're going to talk to them about exactly what they want to do. But we've had preliminary discussions. We talked to the county, we talked to the local community there, and so on. The next thing is Wadsworth. The construction right now is in process. It's already been designed. The bridge replacement is going to be going up this summer when school's out because children use that bridge to go to school. But next summer, that bridge will be replaced. And then the Pyramid Lake Paiute tribe with that situation with the environmental and stream changes, the small incremental changes, we put a fund in escrow for that. And that fund will be able to be accessed as soon as we start construction on Vista Narrows. So that's how mitigation works. You look for these problems, you create a rationale for a fix, a justification for a fix, and then you proceed and then you get these things. And hopefully you have happy stakeholders downstream, which I think we do. I think we have good relationships with everybody on this list here. So that leaves us, okay, we've done all this work, we've done all these designs, everything else. Now what are we going to do? Why, we're at 65%. What we're going to be doing now, and they've already started working on this, we are going to 100%. So what we have now is data collection and survey, because when we did this design, this was done in 2019. It is now 2026. And it took us a long time to get to a place with the Army Corps of Engineers and with the tribe and others with the mitigation to get to a place where we could get to the finalization of the permitting. And so it's been 7 years. So they have to do some more data survey collection. They have to also do more detailed geotechnical for the final design. And what that is boring holes, looking into the dirt to make sure, for instance, there's no mercury, make sure it's usable for whatever we want to use it for, that kind of thing. So that's more work there. We also have more work with easements and right-of-ways because there are some new features out there. There's actually a pipe from the Tum Wharf all the way down to the industrial area, the Trick industrial area. So we've got that to deal with along with other things that have been done in the last 6 to 7 years. We need to do specifications. Those are instructions to allow the that really constrain what the constructor can do and tells them exactly what kind of materials you're supposed to be using for what. But those need to be high. We do have specs, but we need to get them more detailed. Drawings, we have drawings of the whole thing. We have literally dozens and dozens of drawings, but these have to be upgraded to their final and ready for bidding. And that leads us to the next one, bidding. We have to create construction drawings and the specifications and all the contract documents to get ready for a bid for a constructor. Further geotechnical analysis, value engineering. Value engineering is really important because we have newer modeling and we can really check through and make sure we got these terraces exactly right. Small changes in the terrace can save us literally hundreds of thousands of dollars. So we want to double check that with the new modeling we have. And then we also need to evaluate changes in utilities, like we talked about up there. Permitting support, we're still finalizing one of our big permits, but then there's several other permits that we're working on that are more pro forma, but you still have to do a lot of work on them. And then the general support as well. So that's what we're up to now. And this will be going on from about now. Well, actually, it's been going on since December, and it'll probably finish up at the end, around the end of the year, and we'll get into this idea of going out for bid. We already have the money saved, about 75 million right now, enough money to do Vista Narrows. The cost forward of Vista Narrows is roughly, with everything, permitting, uh, all the things combined, the further design work and the construction supervision, all that put together is around $50 million or less. So we do have enough money to do this project right now, but we do have to get this final design and get the permit, the key permit that we need, which is called a 408 from the Army Corps of Engineers. Once we have that, we will be able to start construction. It could start as early as the fall of 2027, more likely in 2028. So this is kind of giving you this idea of when this everything will occur with this final design activity. And you can see that early next year is when the target would be to go out to bid, and the permit also would have to go. We're gonna have a separate talk on the permitting and the environmental here in a second, but this gives you an idea of where we're at with the design work that we're going to be doing. And like I said, somewhere in here with the design development, design support, we're doing value engineering and cost analysis and lots of other things there in order to get to the place where we have this 100% design and bit, construction drawings, etc. So that's where we're at with Vista Narrows. It's really exciting. We're getting to the point where, you can see the light at the end of the tunnel finally to get this into construction for these terraces. So with that, I think we're ready for questions. Any questions at all?
All right, go ahead.
I think it says Spark. You've got your mute on still.
Sorry. Now, can you hear me now?
Yes.
Okay, so this was great presentation and really helped me understand what you're doing there, and that there's a lot of downstream work that I didn't understand had to happen. I mean, knew about the bridge in Wadsworth, but not the rest of it. So that was really interesting. I did have a question. It looks like you're opening up the terrace area right above the railroad bridge, but nothing on the other side of the bridge. So I was just curious, because does that make a notch point then at the railroad bridge?
The railroad bridge does limit flow somewhat. However, the terraces opening up does open it up as much as we have. And like I said, if we had all those terraces open, it would be 3,600. Right now, it's around 2,400. But there is a bit of a constraint there at the bridge, yes.
And, but you had an agreement, I think, with the tribe that you wouldn't go over 3,000? Is that what I heard you say one time?
2,400, and we have a very detailed two-dimensional model that we use to figure that out to make sure that we are not going over 2,400.
Okay,
And in fact, our latest calculations is we're under that by a few hundred CFS, and we would like to keep a little bit of a play area there, safe zone, conservative. We don't want to go right up to 2,400, but the way we're designing the whole project, we want to keep, yeah, we're required to keep it under 2,400. We'd like to keep it a couple of hundred under that even.
yeah, because the modeling and everything has a little bit of uncertainty to it, as you know. And so, yeah, you don't want to be right at the limit, obviously. So that looks like it's a
Exactly.
very smart
Yep.
move.
Yep. And the newer model is a calibrated model, so it is more exact, or more, I won't, exact isn't the right word. It's more accurate than
Okay.
the earlier model we had. So that's nice too. We spent about $1 million on a model for the physical map revision, and that model is a calibrated model, which makes it much more reliable and something we can work with and defend and use better.
Again, thank you.
Thanks. Any other questions?
Go ahead, Daniel.
Hi, yeah, I'm Daniel Cause. I'm a fish biologist with U.S. Fish and Wildlife Service. I had some connectivity issues, so I may have missed this. I'm just wondering, at what flow rate would you start to see floodplain connectivity with those terraces being inundated? And is that something that would occur often enough that it would play as a factor into improving fish habitat? I know a lot of floodplain areas can provide really good rearing habitat. I just didn't know if the modeling considered how frequently or what type of event, if it's only, that 100-year event that you showed that would have inundation, or if you would see pretty consistent.
The lowest floodplain that we're carving out would get inundated all the time. I mean, not like every day, but it gets inundated. Like even a flood like what we're going to see in the next couple of days would inundate that. So
Okay.
like a 5-year would do it, a 2-year. So and then there's several other floodplains. Let me just I want to show this to you real fast. And there may be more on this with Danielle's presentation, so I don't want to steal her thunder too much here. Wow. Okay, there it is right here. See how where it says 100 to 1 right here? That super low floodplain there is only just above a foot or two. So that gets hit all the time. The 10 to 1 area, that as it goes up, that's getting somewhat lit to some area along here, even at lower flows, even at lower flood flows. They're not low flows, but they're, like what we're seeing in the next few days. That would be
Okay.
wet. Yes.
Thank you. And then, as the inundation, as water levels will drop back, at this design phase, have you considered how consistent connection to the river would be as those water levels drop back down? I'm just wondering in terms of maintaining, if these areas are inundated during higher flows, is that connection, will that be a connection that's maintained with the Truckee River as water levels drop back, or is it a risk of potentially stranding any fish that moved into those terraces with the higher flows?
Yeah, and that's a detailing that we're doing in the final design.
Okay.
That's something if you want to look at, help us out with. I mean, I used to be the in-stream flow specialist for Oregon, and it's something I'm very aware of and sensitive to myself. So yeah, but that's a detailing item, how we, and you can notice, see how it's a 10 to 1 like that. It's a 10% here, and even here it's got some slope. We're not just doing flat. We do have some areas of wetlands, so some of those might get some stranding in those wetlands. So we'd have to be careful about that. So that's something that we'll definitely be looking at in the how it's really aligned in the final design. to prevent that. That's definitely a concern. And one too is we don't have, well, I mean, the water goes down pretty fast, but it's not like a hydropower project where they ramp. So hopefully that slowness of the drawdown will be okay too, because there is that too. The water's backed up, it's going down very slowly. So that might be helpful too. So we have to look at all that, and that is a detailing item. I hope that helps.
Yeah, that answers my question. Thank you.
Any other questions?
Looks
Great
like
questions, by the way.
looks like we're all good in questions.
Yeah, it's a pretty small group today. I expect a lot more when we actually get into the final design, like the 90%. But I just wanted to do kind of a catch-up talk here to get people oriented again to what Vista is. It's a major project. It's on the same scale as Rock McCarran, and in some ways it's more foundational and important. I know it doesn't do a bunch of fields and stuff, but it is really, really important for the area. And like I said, there's a lot of ecological issues, and that's what Danielle's presentation is going to be about. And so I think I'm going to bow out here and let Danielle take over with what she has to say, which is more about the permitting and the ecological part of this.
Okay. Well, thank you very much, George. I am going to attempt to share my screen. So,
Yeah, let me get out of it for you.
okay.
Stop it. There you go.
And then let me see if I can do this. And I just want this one. And okay. Then let's
You
do,
got it.
do here we go. So can you all see just the slide?
No, it's on the like the
Why is
slide
it
on the side and then the other major slide.
Okay, I don't know why it's.
You got to start the slideshow and go to that screen. You're still on the wrong screen.
Yeah, hang on. Stop share. Okay, and then let me share again. Here we go. All right. Now can you see it?
Yep.
That looks correct. Okay, and I got let me get to this one. There we go. Sorry about that. Okay. Once again, my name is Danielle Henderson. I'm the Natural Resource Manager for the Truckee River Flood Management Authority. And as George mentioned, he gave a really great detailed overview of the Vista Narrows project. And what I'm hoping to do is focus more on the environmental features and also the permitting. So from that kind of perspective. And just to step back for one moment here, again, we're trying to sort of reorient ourselves in terms of ecosystems and this environmental perspective. I just wanted to bring up this idea of ecosystem services. I think we can all argue that healthy ecosystems have intrinsic value, but they also have value because they help create healthy communities. And these ecosystem services, this concept of ecosystem services, these are benefits that ecosystems provide to people. And there's been some research that's happened over the years to categorize these types of ecosystem services. We have provisioning services, regulating services, cultural and supporting services. And so you can see from this slide, there's all of these benefits that people can obtain from ecosystems, as well as, again, just, having functional ecosystems for the planet, for, the beauty and all of that. So there's some really important stuff in here. And I think what's important to note here is that natural floodplain systems do provide a variety of these ecosystem services. Many of those fall under the category of regulating services, in terms of flood mitigation, erosion control, groundwater recharge, and even water quality improvement. And also some of these foundational supporting services. These are the processes and functions that basically sustain life on Earth. And so some of these supporting services include habitat provisioning and also maintenance and enhancement of biodiversity, which is very important in Nevada. We are in a desert ecosystem, and so these floodplains support and enhance a large portion of biodiversity in our state. I think it's also important to note here that the ability of an ecosystem to provide these services depends on its functional properties. So the health of that ecosystem is very important. And excuse me, as we have changed the land use and developed in the floodplain, it ends up resulting in floodplain disconnection and also altered flow, which also leads to an increased risk of flooding and flood damage. So these are all important things to consider as we move forward. We at the Flood Authority have always kept this community vision in mind. And I just wanted to, this project has been in the works for a really long time. We're excited that it's finally coming to 100% design and that we're getting started, hopefully going to construction soon, like George mentioned. Years and years ago, the old community coalition, public stakeholders, we developed this vision for the project as a whole. And that is, again, to create this healthy, functional system that achieves these flood protection goals that George talked about with a combination of infrastructure, but also land acquisitions to preserve the floodplains, as well as in-stream and riparian restoration, and the creation of some recreational opportunities along the river corridor. And we have always known that stakeholder engagement is very key. We've kept this up over the years, and that's why we're having these types of workshops. We've worked with all sorts of other agencies, homeowners, businesses. We've got some outreach campaigns, and we've established ourselves as a resource for the community. So this is something that we've taken very seriously over the years, and this vision informs all of our designs and analyses for these projects. And this slide is kind of a ringer. It's actually for the Rock McCarran project, but I just kind of wanted to touch on, again, this concept of ecosystem services and the fact that the Truckee River is the existing conditions are somewhat degraded at Rock McCarran and also at Vista Narrows. We used to have a very wide floodplain, active floodplain, lots of meander bends and whatnot, and that's in the Meadows area. And as George was mentioning too, the level of these floodplain lands were low, and so they were connected to the river channel. And so that allowed those areas to flood frequently and support riparian and wetland vegetation. And as you'll see later on in my presentation, and as you saw from George's presentation, that's not the case now either at Rock McCarran or at Vista. And so the goal of Vista Narrows and Rock McCarran, and really all of the parts and pieces of the flood project, is to, wherever we can, pursue preservation of natural floodplains and also restoration of the river itself and the adjacent floodplains. And, do that where we have the potential to and where it makes sense to. This would include moving the river channel, creating meander bends. Again, that slows the water, prevents bed scour and bank erosion. We can create fish habitat with some secondary channels. Again, as was discussed earlier, we've got to dial in the details on that to make sure that we're not stranding fish during low flow conditions. We can also construct pools and riffle sequences, again, to improve aquatic habitat diversity and also water quality. In terms of floodplain restoration, we are excavating floodplain terraces. That's certainly a huge portion of what we're doing at Vista. Removing invasive weeds, preserving the existing riparian vegetation, as well as establishing new vegetation communities of native and adapted plants, and creating a functional floodplain ecosystem once again. And again, this gets back to that idea of if the river system is healthy, then it can create a healthy community, sustain a healthy community, and provide all of these ecosystem services. So jumping back to Vista Narrows, George talked a little bit about this, but in terms of more of a natural resources perspective, the Vista Narrows sort of comes from this natural bedrock outcrop, the Vista Reefs, which exists in the Truckee River east of Sparks. It creates this channel constriction and causes backwater flooding in the Truckee Meadows. And that's actually how those meadows were formed years ago. I mean, it was a natural process. But because we developed in the floodplain, it led to issues with flooding, flood damages, risk to people and property and whatnot. And so back in the 1960s, portions of those, the bedrock outcrop, the Vista Reefs, were removed in an attempt to do some flood control work and solve this problem. But what ended up happening, this was an unintended consequence, it led to channel incision of the river and also widespread habitat loss. And unfortunately, it also did not solve the problem of backwater flooding at Vista Narrows. And I just wanted to take a moment to acknowledge our design team. We've had lots of different consultants work on this project on the engineering side and on the environmental and cultural resources side. And we're excited that we're working with this incumbent team to move the project to 100% design. And I just wanted to thank everybody for the work that's gone on over all these years. So I won't spend very much time on this slide. George, oriented everyone as far as the reach that we're talking about. And again, the part of the project that we're focusing on now is the floodplain terracing excavation. And as George mentioned, the real goal here is to create a no-rise condition and balance the upstream benefits with downstream impacts, and of course, avoid, minimize, and mitigate those impacts where needed. And this is just the project at a glance. George went over a lot of this, so I won't spend too much time on it. Some of the challenges and constraints that we have, George mentioned some of these. I think I would also say that, we do have a lot of invasive weeds in this area, including tall whitetop. So we have to find a way to address that. And also there's always this question of mercury and the potential for mobilizing that mercury in the sediments and methylation, which of course is a very bad thing. So we've got to address that in our project designs. In terms of construction highlights, we are talking about a lot of excavation here. And again, I want to stress that this is not any excavation or work that's going on in the channel. This is excavating these floodplains on either side of the existing channel. So we're staying out of the channel, but this is still like a significant amount of excavation. 3 floodplain terraces. We started out with 6, but as we iterated the design and figured out exactly what we needed to balance upstream and downstream, we came up with 3 that would do the job. This involves about 8,600 linear feet of riverbank. We are proposing 37 acres of revegetation, including up to about 13 acres of wetlands. So that will all be new habitat that's created as part of this project. And there are some areas, I'll touch on this later in the presentation, but we do have some areas that will require some additional bank stabilization treatments. And so we've got around 700 linear feet of vegetated riprap that's proposed. So George spoke at length about the hydraulics for the project and the modeling. You know, this was extensive work that was done for this project. I just wanted to throw this up here because it's a really cool graphic of model output. And it also shows that we're really trying to optimize these terraces. And this is in terms of the location, the area, the geometry, the different inundation levels, which were touched on in some questions earlier. We are engineering these terraces to inundate frequently enough to sustain the riparian and wetland vegetation, you know, create a sustainable habitat. We want to avoid impacting low flow conditions. And again, you know, balance upstream with downstream, avoid, minimize, mitigate where we need to. And this is an interesting comparison. Again, the previous slide was of Terrace 6. It's the largest terrace, so it's the most exciting one. And here, this is just a comparison, again, of Terrace 6. This is pre-existing conditions and post-construction conditions. And what you can see from these little flow vectors is, you know, the existing conditions out there, there's only partial inundation of the land that's available to be a floodplain, just in terms of, you know, the lateral extent of that land. Right now, it's too high to be inundated. And so only part of it is inundated. There's large areas of ineffective flow. And there's also high energy flow. If you look at these arrows that are going right toward the river channel in yellow, they're impacting those riverbanks. And so it's causing stress on those banks and increasing the risk of erosion, which carries with it sedimentation issues and water quality problems, things like that. So contrast that with post-construction and this engineered floodplain terrace that's been excavated to provide much more consistent inundation of that floodplain, really activating that entire area for the benefit of, you know, maintaining this habitat. The ineffective flow areas are greatly reduced. And also you can see that the flow lines, you know, the direction and the velocities have been reduced and redirected away from the banks. And so you're not putting that stress on the banks and, you know, you're decreasing the risk of erosion. So in terms of revegetation, because that's kind of the second part of this, right? Like the first part is to excavate the terraces and, you know, do all of the construction for flood control benefits. And then the second part of this is to revegetate those terrace surfaces. So we're actually creating that riparian and wetland habitat. You saw one of these graphics earlier in George's talk, but to sort of reiterate the importance of this, again, we're talking about a lot of excavation and lowering the existing ground to create these terraces that actually do have sort of a gentle slope that ends up tying in with existing ground at the back end. And as it slopes up, we've keyed that into different levels and frequencies of inundation that supports different types of vegetation communities. And so what you see here in this photo is, again, one of these like cut banks. That's about 15 feet of cut bank, vertical banks here that are just sort of sloughing off into the river, creating these erosion and sedimentation issues, water quality issues. And you can see that the vegetation that is up on this, you know, old terrace surface. It's no longer connected to the channel and to seasonal groundwater fluctuations. And so it can't support the riparian and wetland vegetation. Those plants require frequent inundation and their roots need to be close to that water table. So you can see here in this other schematic, this is just sort of a typical schematic of what the revegetation and the elements of the terrace will look like. Excuse me. And this is for the cottonwood, woodland, and seasonal wetland areas. And let's see. I'll get to that in a minute. So as I mentioned before, there are some areas where we do need to do some additional bank stabilization treatments. These are vertical banks, again, these sort of actively eroding areas. And the existing buildings and infrastructure that are nearby are at risk. And so what we're proposing, because of we have sort of limited area to work within there, and so we can't lay the banks back and create these very gentle slopes where we could achieve bank stabilization with vegetation only treatments. So we do need to do some revetments in that area with rock riprap. However, we're not a fan of rock riprap, and the resource agencies do not support the use of rock riprap. And so what we've done is come up with an alternative where we will be interplanting willow poles within these riprap sections. And so we'll be able to stabilize the riverbanks in this area, protect this infrastructure, while also creating some habitat for birds and insects, etc. The willows that are planted closer to the stream bank will also help to shade the river and create lower water temperatures, which can benefit fish and other aquatic species. So we're hoping that once these willows are established on these revetment areas, it'll also sort of be, it'll increase the aesthetics because the willows will sort of take over and visually you won't really notice the rock quite as much. So that's the hope with these areas. I will say during the 100% design phase, as we move to final design, we're going to be refining the models and the design details. And so it may be possible to reduce the amount of riprap that's required, just if we can sort of fine tune the project designs. So that's also a hope. It could end up being less than 700 linear feet. In terms of the revegetation plan details, again, we've got this sort of artist rendering of what the project might look like. One of the, terrace 6, these wide terraces. Once we're done excavating and the vegetation is established, this is what we hope it'll look like. And you can see from this cross section here, we've got the different vegetation communities that again are keyed into the inundation frequencies for each portion of this terrace. As
Danielle,
yeah.
I don't think you're advancing your slides.
Oh, there we go. Sorry about that.
No problem.
Okay, so we've got the artist rendering. Sorry if you didn't see that before. And here's the cross section of the sort of revegetated terrace area. Again, we've got these riparian woodlands and seasonal wetlands right near the existing river channel. So those would be inundated frequently. Someone asked earlier about how frequently they would be inundated. They're designed to be inundated like every 1 to 2 years. And then as we move up in the terrace, away from the river a little bit and a little bit higher in elevation, we move to more of a dry riparian shrub community, woods rose, silver buffalo berry, those types of of plants as well as some grasses. Those areas might be inundated around the 5-year frequency. And then eventually we'll move up a little bit higher into reclaimed upland areas with plants that are more xeric. So they're more drought tolerant, tolerant of dry periods. Those would include species like four-winged saltbush. And then eventually the excavated terrace ties in with existing ground. And part of what we're doing with the revegetation effort also will be to amend the soil if we need to, as well as pre-treat weeds and really try to create conditions that will maximize the success of this revegetation effort. And this is going to be a multi-year effort. It's going to take, it could take 3 to 5 to 7 years to really establish this vegetation community on these terraces. So we're going to do everything we can upfront to really give it a jump start. And then hopefully over time, the native plants and the conditions that we've set up to favor those native plant communities will allow those plants to outcompete the weeds. And we recognize that over time, we will still have to come in and do maintenance, even from a flood control standpoint, just to make sure that the project is continuing to convey flows the way we've intended to maintain those benefits upstream. But the idea, again, is to create a sustainable habitat based on the conditions and the floodplain function that we're setting up with excavation of these terraces. Okay, let me make sure. Okay. Some other environmental considerations that we looked at when we were designing these terraces. We sampled the soils for mercury and other heavy metals. We did this at the existing surface and also at depth. So that would be at the depth that the terraces would be excavated. So, 10 to 15 feet in some areas. Thankfully, no heavy metals near limits were detected with those samples. And I will talk about this in a second also, but we are using lessons learned and methods from the Nature Conservancy's ecosystem restoration projects downstream to inform designs for revegetation and also for configuration and the slopes of these terraces. Again, to sort of key in inundation with plant communities and match those up so that we have the greatest success. Most work will be done at or above the existing stream banks. So again, we are trying not to have disturbance in the stream channel. And to prevent mercury methylation, the wetlands that we are proposing are shallow and also designed to reduce long-term water holding. So it's more of a flow-through system and a seasonal wetland. I just wanted to sort of touch on this other work that we've done because it has been really important for informing the Vista Narrows project, as well as designs upstream, like you saw before with the Rock McCarran project. We've been involved for many years in ecosystem restoration efforts on the lower Truckee River reach. We've partnered with various agencies and nonprofits to help implement this restoration program over a period of years. We've invested money into doing this, and we had some grant money. And the benefits that were the goals of these ecosystem restoration projects included, again, this floodplain activation, decreased risk of developed property damage because we're preserving floodplains, increased stream bank stability and water quality improvement in terms of erosion, limitation, sediment, and temperature. All in all, we've helped restore about 8 miles of the river and created over 450 acres of habitat in and along the lower Truckee River. This map that's on the slide here is from some older planning documents. The entire lower river was broken up into these reaches, and then they were evaluated by other experts and consultants back in the day for the potential for restoration and sort of like what level of restoration might be required in order to realize that maximum potential. This was done way back when we were working with the Corps of Engineers, but also a local consortium of all of these local, state, federal agencies, nonprofits like the Nature Conservancy. We all came together. And so some of these projects have been implemented and some of them are still sort of on the books, but lower priority. And a lot of the grant money was coming from Desert Terminal Lakes funding, and that money has largely been spent successfully. But so there hasn't been much opportunity to continue working on these projects. But they've been very important for, again, informing the designs and keeping that vision of the healthy, functioning Truckee River in mind for our flood project elements. The first project that was done as part of this effort was done by the Nature Conservancy at their McCarran Ranch Preserve. And this project really served as a blueprint for Truckee River restoration. And that's in terms of methods of restoration and techniques for working with the river and also for revegetating and creating these riparian and wetland areas, but also in terms of navigating the regulatory permitting process. The Truckee River is actually a very highly regulated river, and there's quite a process that you have to go through in order to work in and around the river channel. And so this project really, again, served as a blueprint for how to do these projects on the lower river. So it was super helpful. And I'll just touch on a few of these other projects that we participated in. One of them was the Lockwood Restoration Project. This is just downstream of Vista Narrows and close to where George was talking about Long Valley Creek and Rainbow Bend. There is an ecosystem restoration project there, and there's actually a recreational trailhead there too that you're welcome to enjoy. It's managed by Washoe County Parks Department. This is an interesting project because, the river is still fairly constrained in this area, and we did not do a lot of in-channel work here, but we still managed to create a nice meander bend with some backwater habitat, some pools and riffles in the channel, and create this riparian habitat in the floodplains. So this is kind of a, I guess, smaller scale project. The flip side of that is one of these larger scale projects. This was at the 102 Ranch. And again, we helped participate in this, helped the Nature Conservancy. They took the lead, but we provided technical expertise and oversight and also some funding for this project. And this is a very large project, over 100 acres of wetland and riparian habitat, lots of meander bends. You can see, riffles, pool sequences, backwater habitat. So this is sort of the I guess high level restoration that's been done on the river. So those are just some examples of those types of projects. And again, they're really important because not only are we restoring that lower river and the floodplain function, but we're using that information to inform the designs for projects like Vista Narrows, Rock McCarran, and other elements of the flood project. George has talked previously about the downstream impacts that were studied. We've worked with Pyramid Lake Paiute Tribe. And again, we're making sure that we address these impacts, avoid, minimize, and mitigate those impacts where we need to, so that we make sure we do no harm. That's another one of these key concepts of flood control. This slide is just a summary of all of the environmental work that's gone on to support the design process and the permitting process for the Vista Narrows project. We have generated lots of studies and reports, including, as I mentioned before, the metals testing rather, of soils. We've done cultural resource inventories, wetland delineations, biological surveys, and all of that information fed into big deliverables like that revegetation plan, a weed control plan, and even a dewatering plan for during construction. And we've also been doing a lot of coordination and planning. Again, we've got all of those lower Truckee River restoration sites and the work that was done by the partners to inform our designs. We've also contacted several different nurseries and suppliers of soil amendments, compost, seeds, so that we can try to get a handle on what types of materials are available and what might be most successful for revegetating, whether it's containerized plants or seeds, soil amendments, weed control methods, all of those sorts of things, nurse crops. So, we're talking about, 37 acres. We need a lot of plant material for this project, and we need to figure out how to have that plant material online, available and ready for planting when the terraces are excavated. So the revegetation really does have to sync up with the major construction on site, because we can't just have a bunch of raw dirt out there. We'd have dust issues, air quality issues, and also weed control issues, things like that. So it's something that we've been working on and will continue to work on as we get to 100% design. We also consulted with an outside expert on the bioengineering designs for those vegetated riprap areas. So that was really helpful. I'm going to switch gears just a little bit and talk about the regulatory permitting requirements for the project. I won't really get into the details on this slide. It is a little bit, I don't know, confusing, and it's a long history, but the point is we've been involved in a permitting process for the flood project as a whole for a long time. And it's morphed and changed over the years. And basically, we've tried to streamline this process. We're working with the Corps of Engineers on permitting. They're the lead federal agency. And we did manage to streamline things by deauthorizing this old project that was not going to provide the benefits that the community wanted to see in terms of flood control. And the bottom line here is that we've submitted an updated application package for the big permits that we need from the Corps of Engineers, and submitted a draft environmental assessment, which is currently under review. So all this is to say that, again, navigating this permitting process and working with the federal government, it's a long process, and we're making progress, but it has definitely changed over the years. This is just a summary of the permits that are required for construction. Again, we have this major permit, the Section 408, 404 application package. That includes a whole host of documents and supporting materials that go along with that package, including biological reports, cultural resource inventories, the revegetation plans, biological assessments, those minimization measures for the impacts, and also the hydrology and hydraulic assessments. We also have other permits and authorizations that are required, including special use permits, grading permits. Part of the project, George showed the property map, and there is a parcel of land that's managed by the Bureau of Land Management. So we have to apply for a permit for BLM. We've got encroachment permits, easements, construction permits, and other permissions like dealing with the railroad. So we've got a ways to go on some of these, more localized or specific permits. But we've made good progress and certainly have been working for a long time on the 408, 404 package. Again, we made a lot of progress in 2025 and it was very encouraging. And this was part of why we decided to move forward to 100% design with Vista Narrows, because as you know, we can't construct the project until we get permits. And so, like I said, we submitted this updated application package. We drafted an environmental assessment. The Corps of Engineers actually got back to us. They reviewed the documents and sent us comments. And we have since revised the environmental assessment, responded to their comments, which they had roughly 100 comments by the time it was all said and done. We're still in the process of addressing a few of those comments, but we've given them an updated version of the EA and a response to comment log. So all of that is very positive. And again, we were encouraged that they were able to review our documents in a timely manner. Moving forward in 2026, again, we're going to 100% design with our incumbent team. We've got hydraulic modeling work underway to better characterize the effects of just the Vista Narrows terracing work as a standalone project. We really want to bring that out in the environmental documentation. Again, really trying to characterize those effects and the fact that we are avoiding, minimizing, and mitigating whatever effects we have from this project. We're continuing our cultural resources work and coordinating with tribal representatives. And again, as part of this follow-up from comments that we received from the Corps, we're planning on sending the Corps of Engineers draft 90% specs so that they can look at those details and give us any feedback they might have before we finalize those at 100% for bid documents. In terms of other environmental work that we are doing as part of this 100% design phase, we did submit that application to BLM. We need to do that because we're essentially building facilities on federal lands. We're also coordinating with the Nevada Department of Transportation about the Vista Narrows project and their I-80 East widening project. And this is in terms of environmental issues and also an encroachment permit. Again, we've got upcoming hydraulic modeling work to refine that terrace geometry. And like I mentioned earlier, we're really hoping that we can minimize that bank stabilization that's required, and working on logistics for growing those plant materials and sequencing the revegetation immediately following the terrace excavation. So in summary, I think some of these take-home messages are basically that I just want everyone to understand that the agency remains committed to that original vision that was put forward by the Community Coalition. And our goal is really to design and construct a project that reduces flood risk, but also provides these other benefits and recreational opportunities in order to create a more resilient and sustainable community. As you can see from George's talk and my presentation, we're using the best available tools and technical information that we have and some innovative methods in order to achieve this goal. And as I discussed, the ecosystem restoration projects that we participated in the downstream reach have really served as a great reference for Vista Narrows and other portions of the flood project. And with that, I'm happy to open it up for questions and discussions, either on this portion of the presentation, or George and I can answer any other questions that you might have on the project. And thank you very much for your time. And I will, let's see, I can stop sharing my screen. Okay. And I don't know, am I facilitating this or?
I've still got it. I put it on my phone. So does anybody have any questions? Go ahead and raise your hand.
I see a couple of. Marissa, I can
Okay,
go ahead and
yeah,
ask your question. Yeah.
okay. Um, uh, are there any plans to make those terraces accessible for recreational purposes, like maybe footpath or I'm not sure if the tall pyramid you know, path goes through there or if there's other maybe walking path that may be opened for the public.
Right. So this is a great question. And, in general, we definitely support opening these areas up for recreation and having these paths. We will require some maintenance roads and pathways to access these terrace surfaces so that we can prune vegetation if we need to, go out and clean things, inspect the channel in the project. The Vista Narrows reach and project area does not, it doesn't have as much of an opportunity for access as other areas of the project. It is constrained. We're kind of pinched between, I-80 and the railroad and private property, et cetera. And access is kind of an issue too in terms of parking, like where you would park your vehicle and be able to get out safely. So we haven't really designed a lot of recreational features for this, but I think we are coordinating with the Tahoe Pyramid Trail and, actually George and I had a meeting with them fairly recently. So the idea would be, coordinate with them if there are opportunities to allow access in this area. We're happy to facilitate that. But again, it is a little bit tricky just because of parking and access for vehicles. And there are some cultural resources in the area that need to be protected. So those are some of the issues on that site. But definitely the Lockwood trailhead is a really nice site. And part of the Pyramid Trail runs through there as well. So.
Yeah, a big deal is that a lot of that property is private property.
Oh.
And so we don't have control over, let's have access through private property. Like Rock McCarran, we control that property, so we can do that there. But here we're at the mercy of some of that with the private property. But there will be, like Danielle said, there are those roads and they will provide access, but it's more ad hoc. It's not going to be like we have a recreation area and a trailhead like we do it like Lockwood has, for instance. We're not going to be having that.
It's like not advertised as a recreation.
Right.
Right.
It might be, again, like if we can secure easements and have those, roads and pathways for maintenance, we might be able to just allow pass through, right? So it's a connector. It's more of a connector portion, but not really like a feature that you would go to spend time at. So I hope that makes sense. Let's see. Go ahead, Roger.
Yeah, I just had a quick comment. I saw on one of your 219 drawings that you had a whole bunch of cottonwoods along the river. Is that still planned?
219 drawings. For the Vista Narrows Reach, we are doing a lot of willows and we may do some cottonwoods in that area. There will be overstory plants,
Okay.
and woody vegetation.
No, I heard you mention
yes.
earlier that you're gonna have willows planted in there, which is a good material to hold the material there. But
Oh, yeah.
I also saw in one of those earlier drawings that there were cottonwoods along the river, which of course gives you even better shade than what the willows do. And of course,
Mhm.
they're a typical vegetation that we expect along like the Truckee River. So I thought that was interesting. I just didn't know if that was still the plan. I didn't hear you mention cottonwoods earlier.
Oh, I thought I had. If I didn't, I apologize. Yeah, we've got cottonwood woodland areas, riparian woodlands, as well as wetland areas. So yeah, even some of those grasses, sedges, rushes, they've got those really fibrous roots that hold that soil and stabilize stream banks very nicely. So yeah, so we've definitely gotten plant communities and some plant palettes figured out for that.
Good, thank you.
Mm-hmm. Yeah, anybody else? I know we're approaching time. Yeah, go ahead, Marissa.
The other question I had, I think it's like Terrace 6, the big one.
Yeah.
Since, the water is going to flow rather slowly, do you have to expect that there is a lot of sediment deposit on the terrace? And
I would think, yeah, I mean, some of the sediment will drop out during those seasonal flood events, but that's all part of the natural floodplain function. That sediment should include a lot of nutrients in with the soil particles. And so it'll actually help the riparian vegetation, the willows, the cottonwoods, and the wetland plants to be more robust.
but not to the point that you would say like, oh, after a few years, it's going to be filled up there.
Well, that's why we need to have access to these sites and be able to inspect and make sure that things are, performing as designed. If we needed to, we could probably, excavate some of that, but I don't think it's not designed to be a really heavy deposition area. I mean, you can see those flow lines do travel downstream. So it has been designed and engineered to carry the majority of that water downstream. Some of it obviously is activating those floodplains, and because it's slow, it will drop out some sediment. But I think the main thing is that the banks that are eroding currently are going to be stabilized with vegetation and in some cases, that vegetated riprap. And so you'll actually have a much better scenario in terms of erosion and sedimentation. So,
Thank you.
yeah, you're welcome. Anyone else?
All right. Well, thank you for joining us. It's a little smaller group than normal, but like I said, we'll be in a few months having a 90% presentation for Vista Narrows, and we'll also be having a presentation here soon about the 30% for Rock McCarran, and I have a feeling there'll be a lot of people at that one. So anyways, thanks again for coming and kind of getting a catch up on what we're doing on Vista Narrows. Thanks again.
Yes.
Yeah, thank you
Thank you,
very
everybody. And this is already up on YouTube. I live streamed it there. So if you want to watch it, you can go there to the TRFMA YouTube.
much.
Thank you, George and Danielle.
Thanks,
Thank you,
Dick.
Dick.
Hey, it's good to see you. All right.
All right. Goodbye, everybody.
Bye.